All right, jumping right into 9.3, we are starting graphing our quadratic functions. All right, so we've used our standard form before. If you've forgotten, that is just ax squared plus bx plus c, where a, b, and c are just whole numbers. They're coefficients, no variables. So a, in this case, is 1. We're looking at this equation, y equals x squared minus 2x minus 3. So my b value is negative 2, and my c value is negative 3, making sure to keep the sign in front. Now we want to use our formula to find the axis of symmetry, all right? Because that's what we need to find first before the vertex. So notice it's x equals negative b over 2a. So I have a negative, and then b is negative 2 over 2 times 1. All right, so a negative and a negative, the double negative, makes it a positive 2 on top and a 2 on bottom to give me an answer of 1. So x equals 1. That's my axis of symmetry. So what that tells me is on my graph, that dashed line is a vertical line at x equals 1. That's where my graph is symmetric, right? So the left side should match the right side. All right, the other cool thing about the axis of symmetry is that every single time it goes through your vertex. So we know for sure the x value of the vertex is 1. All right, now you might be wondering, well, how do I find the y value? Well, if we look up here, we have an equation that y equals something with x's. So we can plug 1 in for x, and our output will be the y value. So 1 squared minus 2 times 1 minus 3. Everything is the exact same that it started with, except instead of x, I've replaced it with 1. So 1 squared is 1, minus 2 minus 3. And this gives us negative 4. So that is my y value of my vertex. So now I can go to the point 1 comma negative 4, put a point, and that's my vertex. That's where my graph is stemming from. All right. Next thing we can find, well, actually, even before that, maybe you noticed the x squared is positive, so that should tell you the graph is opening up for one thing. And another thing we can find is our y-intercept. All right, if you are looking at the y-intercept, that means you are somewhere on the y-axis. So if you're on the y-axis, that means you haven't moved left or right from the origin point. So that's why our x value is always 0 for the y-intercept. So if you forget, you can always just plug 0 in, and it'll tell you the y-intercept. So 0 squared minus 2 times 0 minus 3 is equal to negative 3. All right, the other thing you can do is notice it tells us it's at 0 comma c. Well, we said our c value was negative 3, so we could have done it that way as well. All right, so if I plot the point 0, negative 3, I have it. Now, since this graph is symmetrical, whatever's on the left side can get flipped over on the right side. So this point is one space away from the axis of symmetry, so I'm going to go one space in the other direction. Now it's symmetrical, and I can draw my sketch. All right, so this is a very long process to solve or to graph a quadratic function, all right? But we kind of need to follow these steps. We don't have a lot of freedom or leeway this time. All right, so you find your A, B, and C. You find your axis of symmetry to find your vertex. Once you have your vertex, you have your starting point. So then you can graph the intercept and just reflect. All right, let's do a couple more. So let's scroll down. All right, maybe you notice that I have a couple of these marked off. That's because it's the exact same equation. So your life just got a little bit easier, 2 less math problems. All right, so the first one, y equals x squared minus 4x plus 3. My a value is 1. my B value is -4, my C value is 3. So in order to find my axis of symmetry, notice it has the x in it for axis, so x equals -b over 2a. All right, so I have a -4 over 2 times 1 gives me +4 over 2, or just 2. So my axis of symmetry is x equals 2. So what I like to do is go over to where x equals 2 and draw a dashed vertical line in a different color if you have it. All right, so because I know that my axis of symmetry goes through my vertex, I know the x value of the vertex is 2. So if I want to find the y value, I just plug that 2 in for x and get the y as the output. So 2 squared minus 4 times 2 plus 3 is equal to 4 minus 8 plus 3, which is -1. So our vertex is at 2, -1. Let's draw that in. All right, this time my y-intercept, I can just look at my c value. In this case, it's 3. So I know I go up 3, and there's a point. All right, so let's write that as 0, 3. So now the last thing we do is just says new point. Well, remember, since the graph is symmetrical, we can just reflect it across the axis of symmetry. So that second point, the y-intercept, is 2 spaces away from the axis of symmetry. So I'm going to go 2 spaces in the other direction, and I have my function line, and that point is at 4, 3. Alrighty, one more. This time we have y equals -x squared minus 2x plus 2. So my a value is -1, my b value is -2, my c value is +2. So to find my axis of symmetry, x equals -b over 2a. So I have a -2 on top, 2 times -1 on bottom. All right, so we have a negative outside, a -2, and a -2 on the top and bottom. So -2 divided by -2 is +1, but then we still have that third negative on the outside, so it turns it to a -1. So my axis of symmetry, x equals -1. All right, let's draw that in with a different color. I'm going to go where x equals -1, and I have my dashed line. So I know my vertex is somewhere on that line, meaning the x value has to be -1. All right, so let's plug -1 in and see what we get. So negative parenthesis -1 squared, parentheses are key, minus 2 times -1 plus 2. So -1 squared, -1 times -1 is +1, but then we're still multiplying by that second negative sign on the outside. So it turns it to a -1. -2 times -1, +2, plus 2. So we get an output of 3. So our vertex is at -1, 3. So right there. Alrighty. So this time our vertex is above the x-axis. But which way does our graph open? Does it open up or down? Well, we don't need to figure that out. We could just continue graphing, but it is a nice thing to get a little insight of what the final product's going to be. So I see a -x squared. Since my x squared term is negative, that tells me that it's opening down. All right, so let's find the y-intercept. I can just look at my c value. In this case, it's 2. So 0, 2. All right, and now I need one more point for this graph. So I'm just going to reflect it across that axis of symmetry. That point is at -2, 2. All right, so there is our graph, and there are the notes for the day. All right, this is, again, a long process. It's something that is very important in math. The quadratics are, that is. All right, so we need to know how to do this process, and we need to practice it a little bit. All right, so make sure we get the LT check done. You can do it as many times as you want.